Well, welcome everyone today to our Trees and Farming Perfect Partners session, brought to you by the Prime Ministry's Climate Challenges Centre and Agriculture Victoria, teaming up with the folks at Melbourne Uni. So thanks for joining. I'd like to also acknowledge traditional owners on the lands on which we're all meeting today and pay my respects to elders past and present. First of all, welcome Hugh. So Hugh Stewart. I'll just read your CV, Hugh. So Hugh's a professional forester with his feet firmly standing on both agriculture and farming. Hugh graduated from the School of Forestry back in '72 and went on to complete forestry degrees at Melbourne Uni in '75 and '87, and plus a doctorate at Charles Sturt Uni in 2009. So working for 20 years with the Victorian Forest Commission in forest research, so across areas of soils, nutrition, hydrology, irrigated forestry, silviculture and plantation management. Hugh then went to work with the Victorian Plantations Corporation as statewide plantations manager from 93 up until 1998, and then on with Tree Corp Group up to 2005. So Hugh's been a forestry consultant since 2009, working in areas such as forest certification, carbon farming estimation and audits, farm forestry, revegetation, and also did some international work with smallholder forestry projects in Indonesia and Zimbabwe. So Hugh's other current activities are Director of the Natural Resources Conservation League of Victoria and undertaking agroforestry activities on the family farm at Deans Marsh. So with a history of forestry and farming and experience that modelling, but also importantly the actual measurement and growing of trees, Hugh's kind enough to share some of the tools he uses so he can share some insights into tree growing and carbon on farms. So welcome today, Hugh.
Good afternoon, everybody, and Graeme, and thanks for the invitation. Graeme, I'll just share slide 2 now, which gives the introduction to the presentation today. And if I just go to the dashboard, I'd just like to briefly describe the subjects that we'll cover. So the first thing I want to do is to have a look at some of the tools that you can use to check information about your farm or your property. And then with Graeme, have a conversation about why plant trees on farm. And then within that context, then talk about trees and carbon sequestration and some of the tools that you might be able to utilise when you're trying to figure out the amount of sequestration that might be occurring on your property in the trees that you've planted. Is there anything else that we're going to cover, Graeme, or does that basically...
That's great. That's great, Hugh. I mean, I think it's just fascinating to get insights through the eyes of a forester for all of these tools that you find really useful. So it's a great opportunity to share that with farmers and everyone else who's trying to make sense of the trees on farms. So go to it.
And Graeme, as an example in demonstrating some of those tools, I'll use our family farm at Deans Marsh that I am a partner in with my brother Andrew and his family, and my 2 sisters. And our family has farmed that land since 1905, so we have a long history on the property, and we've been involved in tree planting in a serious way for about the last 30 odd years. So I'll be able to illustrate some of the things that we've done and some of the things that we've learned during that period. If I just flip over to property information, one of the things that is handy about to do is to check the cadastral information on your property. And so you can go to Map Share Victoria and agree with all of that. And then you can search for an address. So I'm going to put in the address of one of our parcels of land on our farm, which will come up as such. And this is just one of the 5 parcels on our property. you can create a property report for that land, which gives you a lot of information about the property, which is a handy thing to be able to do. And you can also check the overlays that apply to your property. So that link takes you to the Surf Coast Shire planning scheme, and it describes the farming zone and what you can and what you can't do in that zone. And the other thing of interest is that our property has some planning overlays, so you can turn on the overlay button there, and you can see that there are 3 overlays in the planning scheme that apply to our property, and you can click on those, for example, the ESO overlay, and then again that will tell you what you can and can't do on that land. And if you click in the center of the property, you can pull up the longitude and latitude, and it's worth noting that down because when you're doing runs for carbon sequestration, you need to have the coordinates for a point that you might want to model, so you can easily find a point like that. And if you want to, you can estimate the area by going to Tools, Area, then you can just click around the property. This is a very rough estimate, but just to give you an illustration of the way that it works. And you can close the polygon, and that will give you an area saying it's close to 40 hectares. So the other thing that you can do in looking at the cadastral data is you can go to MapShare, which is again part of the Victorian Government's mapping portal. And again, put in the address. Gordon's Lane comes up. And what this gives you is the opportunity to measure area easily. So that does it for you. So 42.7 hectares. And you can also download the shape file for the property, which you can then drop into a GIS mapping platform such as Google Earth or QGIS. So they're just a couple.
And all of these links as we go through, Hugh, they'll be available attached to where you found this Zoom recording, folks. Yeah. So all of your tips for where these great sites are sharing. So thanks.
And I've also made a few notes here in this sheet that we'll share about how to access those various elements. The other thing that is worth looking at on your property is the nature and extent of any remnant vegetation. So this is done through NatureKit. And agree to that. So here I'm going to search for a location, search location, search by address. So I'm going to put in my address. And that comes up. I'm going to search. And what that does, it brings up that parcel of land highlighted in yellow. And if you add it to the drawing layer, it'll then highlight it in orange. If you now click off that tab there and scroll down to vegetation, click on vegetation, that's showing the 2005 ecological vegetation classes on that land, and there are none showing, so there's no remnant vegetation on that piece of land. But to understand what might have been there prior to clearing for agriculture, we can check the pre-1750 ecological vegetation, and you can use the slider to dim that. And then if you go to the base of the map, you can then click on a hybrid option. So if you use the slider, you can then see the aerial imagery, and then you can slide the EVC sort of over the imagery on the property. And then you can click inside one of the EVCs, and that's telling us that that was EVC number 16, which is lowland forests in the Otway Plain. And if you then go to bioregions and benchmarks, which is again a Victorian Government website, it might open up. The internet's a bit slow today. Okay, well, we won't wait for that, but what you can find there is a description of that vegetation. And the significance of this is that if you're trying to revegetate land and you're trying to mimic the original vegetation, this gives you a guide as to what was thought to be there prior to clearing, and it just gives you a guide as to the structure and the species in that vegetation. And so here you can see that it was essentially messmate stringy bark forest with a bit of brown stringy bark and narrow-leaf peppermint as the overstory, and then a whole list of species in the understory. So that's a handy resource. On our property, we have 3 EVCs, and they are really determined by changes in land system on the property. And again, it just gives you a guide as if you're trying to revegetate according to what was the original vegetation on the property. The next thing I'll just skip to is geology and soil. So you can go to Geology Maps for Victoria, and that gives you a whole list of maps at different scale. If you look at, say, the 1 to 100,000 map series, you see that only covers part of the state. So if you then go back to the 1 to 250,000 series, it covers the whole state. And the area of interest to us is the COLAC geology report. And so there you can download the map, and you can also download the detailed report that accompanies that map. And that's a really handy resource. And what I've done here, Graeme, I've just snapped out from that map the area that applies to our property, and we can see TED, the tertiary sediments, and TAE, Cretaceous sediments, and other quaternary sediments on our property. So it just gives you an overview of the geology. Then if you want to drill down into soils, you can go to Victorian Resources Online. And this is a really good resource. We're in the Crangamite region. So in the Crangamite region, you can find a whole host of resources there, which I won't dive into. The other great resource these days is this Visualising Australian Soils Atlas. And if we click into Victoria, have a look at soil series, Crangamite soil groups, so that's the area of interest to us, and then we can zoom into the map. And there's a whole lot of information there on soils. And of course, as you scroll through here, you'll find other data, and there's information on land systems, soil moisture, and what have you. So that's a great resource to have a poke around in as well. So we'll jump out of that. The next thing I was going to mention was climate. So there are fantastic resources at the Bureau of Meteorology website, and this is the access point to get information for long-term rainfall and other climate parameters. when you get into that, you can find great information, including wind roses for the property. And that's really handy if you're trying to figure out the alignment of shelter belts on the property, and you're trying to figure out chill factors and the impact of wind, say, on lambing.
Plenty of southwesterlies coming through there by the looks of
Yes,
it.
yes, they're always prevalent in our region. The other resource that I really like is this future climate resource. So if you go into that, you just type in a location, which I've done, and you select a commodity. So I've selected sheep, and you view the information. And there's a whole stack of information here about climate, past and future predictions for climate. So if we, for example, explore autumn rainfall for pasture growth, it's telling us that under a medium emissions scenario, compared to the last 40 years, in 2030, it'll be wetter in autumn, 148 mil compared to 130. And down the track, it'll still be wetter. If we go to a high emissions scenario, those numbers change a bit. So I'll jump out of that, but there's a lot of information in there, and the information that I really have focused on is the occurrence of frost. And you can delve into that and look for annual cold days. And this becomes important when you're thinking about tree planting and the season of planting and the species that you might select. And it also becomes important when you're thinking about the timing of lambing as well. So there's a lot of information in there that you can tap into and just sort of help inform decisions that you might be making about species of plant and the time of the year to be planting going forward. Okay, so look, there's just one other thing which is a bit of a fun thing. There's a thing called bat map, and if you're interested in fauna, you can go to local bat finder. You can type in your address, and it'll give you a list of bat species that are thought to occur in that locality. So we have about 12 species that are thought to occur in that locality, and we've observed quite a few of those. So it's just something else that you can do when looking at resources on the property.
Fantastic. Nature's insect controllers out there, Hugh.
Exactly. That's
right. They need some trees and some bark and hollows, nooks and crannies to get into. So that's great. I hadn't seen that. Okay, so I think we start talking about tree planting now. I don't know whether you've seen this, Graeme, but this came out of the MLA project I was involved in. So this was done under the Meat and Livestock CN30 project, and they had a module called Trees on Farms, and that was conducted at the University of Melbourne under the leadership of Professor Richard Eckard and Rod Keenan, and it included Ainsley McDonald, Rochelle Meyer, Jane Court, and others, and myself. And one of the things that we produced out of that project was just some steps that you might think about when you're planting trees on the property. So I won't go through all of those, but are there any things there that you think we should focus on, or any comments that you might like to make about those, given your experience? Yeah, I think because there's some good resources from that project, which again will signpost and some important learnings there. But But I think that steps to trees on farms here just runs through. If you're relatively new to what's involved, there's quite a few steps there to make a tree project go well. So all the little tips there that you've put in that. And one key thing just about planning well in advance here, the trees are there for a long time. If you get something wrong by poor species selection, or you've just put them in the wrong soils where they can't handle waterlogging or something, then it can lead to disappointment. So sharing these tips is a pretty good way to approach it. Your first planting, what steps to get in order, and make sure you've actually ordered the trees so your nurseryman has a chance to actually get the species you want. So all of that there. So we'll share that link as well to that.
And Graeme, I think the point you make about learning as you go is a really important one, because we know from our own family experience of planting trees, we've now planted trees every year now for 30 years on the property. And what we've realised is that there are so many different microclimates on the farm, and you don't really understand or discover those until you go through different seasons and you try planting different species in different parts of the property. And so, yes, whilst there's an incentive to try and do a big chunk of planting early on to really get things going, there is a lot to be said to be doing it in stages and sort of learning as you step through the process.
Yeah, no, it's a good thing. Exactly. Learn by doing, rather than try and throw all your eggs in one basket with one big planting. That's right, Hugh.
All right. Okay. So we should start talking about carbon. And there are a number of tools that are available for people to use to try and understand the amount of carbon sequestration that might be occurring on their property in both remnant vegetation and trees that they have planted or trees that they intend to plant. One of those is a tool called PICCC, and it's a tool that's been developed by CSIRO, and it essentially provides a really friendly user interface for the full carbon accounting model, 4CAM, which is the model that generates the estimates of carbon sequestration that goes into the Australia's national carbon accounts. So that's just a bit of information about PICCC. And this is the top.
This is really a tool for farmers if they want to get a bit of an idea about what sort of carbon sequestration trees might be able to do on their farm. This is probably the simplest tool to start with.
Yes, it is, and that's a link to it now. I've been using Safari, which is my preferred browser, but PICCC doesn't open in Safari, so you have to go to Chrome.
Yep.
And if we just paste that into Chrome, then this comes up. So that's the interface. You explore your options, and you can search by location. So I'm going to search by Bamborough, and that will zoom in, and then from that information, I can very quickly find the parcel of land that we were looking at before, which is that parcel of land there. You can then use an area tool to just snap out a part of that property just to get an idea of the carbon abatement that you might be able to achieve. So I've selected 2 hectares, and I'm not going to exclude any areas because it's just open pasture. I'm saying it's a pasture system. I'm going to say no renovation, no fertiliser, no lime. I'm going to a very basic default position. And then I'm going to go next. And that has now generated an estimate on that 2 hectares of the carbon sequestration that's predicted to occur if you were to, for example, reforest part of that land under the environmental or mallee plantings methodology. And it's saying 9.1 tonnes of CO2e per hectare per year over a 25-year period. So that's
Yeah,
just
so that's a nice quick estimate, Hugh. So and any sort of key tips to be aware of for that, because it's assuming an average over the 25 years.
Yeah, it's an average, and so we can look in a couple of minutes at the annual rate of carbon abatement, so you get a feel for how they change in time.
Yeah,
I think one of the things to be aware of is that the estimate of abatement on the property can vary quite a bit depending on changes in land systems on the property and changes in rainfall. The FORCAM model has got an underlying calibration of what it thinks the abatement was of intact remnant native vegetation on the property, and it uses that calibration to make estimates of what you might plant. And on our property, for example, that underlying calibration can vary by a factor of 2 on 230 hectares over a north to south distance of about 3 kilometres, where the rainfall might drop by 40 mil.
Yep.
So if you do that exercise on, say, the north part of your property, and then you do it on the south part of your property, you might get a different result.
Okay. Yep.
Okay.
Yeah. No, that's a good point. And I guess like all models and tools, it's a good one for a quick early scan to give you an idea. And then there's always if you're after more accurate information, then get good advice. But it's a good place.
It's fun to use, and you use it for any part of Australia. So if you think about buying a bit of land, you can zoom in on that, and you can snap it out, and you can do the exercise.
Does it have farm forestry in it, Hugh?
Sorry?
Does it have farm forestry in it too?
It's got plantation forestry, and I don't think it has at the moment. No.
Okay.
Yep. Okay, so if we then move on to the next level of detail about doing carbon estimates, there's the full carbon accounting model FORCAM that we mentioned earlier, and this is used in the national greenhouse gas accounts, and it calculates carbon fluxes or abatement in accordance with the International Panel on Climate Change guidelines. So that's important so that our national accounts are compliant with those IPCC guidelines. And what it does for revegetation, it will calculate carbon stored in above ground biomass and in the coarse woody debris and in the below ground biomass. So it picks up roots, coarse woody debris, forest floor, or what we call forest litter, above ground biomass. It can calculate carbon in soil, but we don't do that when we're making estimates of carbon abatement from revegetation. And
the FORCAM, Hugh, who's sort of best is, like, so for farmers, for a quick look, that look-see is probably the one to go to. Who do you suggest would the FORCAM? Is that more for people who are doing this more regularly?
Yeah, I think it's a tool that is freely available, and with a bit of fiddling around, you can soon get to learn it. And I think that if you have a property that's got quite complex revegetation, then to get a reasonable estimate of the abatement, you need to use FORCAM. And it's also a good thing to be able to use so that you can understand the change in abatement with time, and you can also understand the change in abatement by planting different species and by planting species in different configurations. So it really sort of gives you a lot more opportunity, to explore how you might optimise revegetation for carbon sequestration, taking into account all the other multiple benefits that you're aiming to achieve by planting trees on the property.
Yep.
I'll just go to the full cam detail. So there's a lot of parts to the model, and you input, for example, the geographic coordinates that we pulled out of the property earlier on, and then you have to select the species, and you have to select a management regime and what have you, and you can get a lot of information out of it. But crucially, the information that you derive is the mass in terms in carbon. So it's not CO2 units, it's carbon per hectare in trees, the green line, and the forest debris, the purple line. And the green line includes the roots. So it's the whole trees and it's the debris. So that's an accumulation of carbon over 100 years, but you can then graph that information and calculate the annual increment over the 100-year period. And what it tells you is that the model assumes that the peak rate of annual increment in biomass and hence in carbon sequestration occurs at about age 10. And then by the time it's age 30, it's about a quarter of it was at age 10. And by the time it's age 50, it's about an eighth of what it was at age 10. Yeah. So trees, like any organism, follow a sigmoidal growth pattern, just like kids. They grow fast when they're young, and then when they're our age, they've really slowed down.
That's right. That's a really important one. I know farmers are working on here, that while the forest accumulates more carbon over time, how much it's sequestering per year is basically what's on that graph. So,
yep.
And so for some people who are asking a lot of questions about carbon credits as an income stream, essentially, that's a really key thing to know, that once you plant a plot of trees, that there'll be a change in sequestration rates, which then flows into potential income stream from any carbon scheme. So important consideration.
Okay, the next thing to think about is the planting configuration. So FullCam has a different calibration for a block planting. So there's an example of a block planting on the property that we looked at. This was planted 20 years ago, and you can see the canopies are all fairly uniform, not entirely, but fairly uniform. And then this is an example of a linear or a belt planting on the same property done 20 years ago. And I've just attempted to draw, I think I've just got to move. Yeah, I've attempted to draw the canopies of individual trees and trying to illustrate that the edge trees, which have got more growing space per tree than the inner trees, have got bigger canopies. And bigger canopies translates to bigger trunks and hence more carbon. So FullCam says that if you plant trees in belts, and a belt is defined as a linear planting less than 40 metres wide, it will accredit you with more carbon than if those same trees on the same piece of land were planted in a block, because the edge trees will have more carbon than the internal trees. And this is an example of a belt planting on the same property again. There's a radiata pine belt planting, and this is a belt planting on a property in Western Victoria. And when you generate the outcome from 4CAM, so that's a block. So this is tons of carbon per hectare per year. So we've annualised the abatement.
Yep.
And it also allows you to use a different calibration for a dense planting, more than 1,500 stems per hectare. So say, for argument's sake, you direct seeded versus a regular belt, which is less than 1,500 stems a hectare. So if you just compare the block with the regular belt, there's quite an uplift in sequestration predicted for that configuration. And then when you look at the accumulation over time, you can see that there's quite an uplift, and it can be in the order of 25 to 30%.
Yeah, and that's because trees in belts, they're accessing more nutrients and rainfall.
The edge trees.
Yep, it's that whole edge effect. So they're
It's a whole edge effect.
That's right. Yep. So that's pretty significant for when we're thinking of farm planting. So there's potentially a 15%, more carbon in belts than if you were just doing it as blocks. Yep. Mm.
And of course, when you think about it, if the belt's only 3 rows wide, that's when you're going to get the maximum difference, because you've got 2 edge rows and 1 internal row.
Yep. If
the belt's 30 metres wide, you've got 2 edge rows and probably 8 internal rows.
Yep.
So, but anyhow, the calibration has to draw the line somewhere, and it's drawn the line at 40 metres.
Cool.
Okay. The next thing you mentioned earlier on was how does sequestration change depending on the rate at which you plant trees on the property. So this is just a simulation that I've done where the blue line says you've planted 20 hectares in year 1. Then the orange line says, well, no, I'm going to learn as I go. So you've planted 1 hectare per year for 20 years. And then the green line is where I've done some iteration to try and figure out how can you flatten out the curve of carbon abatement on an annual basis by changing the planting configuration. So this is one where 10 hectares was planted in the first 3 years and 10 hectares over the next 17 years. The significance of this is that if you're running a sheep enterprise, the emissions, which is essentially methane, is going to be pretty well constant. So if you're looking at trees as an offset, you've got to think about, well, am I going to try and configure my planting so I get to a point for a period of time, for example, scenario 3, for about 10 years, I've got pretty constant annual sequestration by what I've planted? Or do I want to go in hard and early and do a big hit and try and get ahead of the game? So, there's an argument that if you want to make a big change quickly to try and suck as much carbon out of the atmosphere as you can, then you should go for scenario 1, but that requires a lot of capital and a lot of resource in a short period of time. Or you can say, I'm going to do 1 hectare a year for 20 years, learn as I go. So that gives you that sort of annual sequestration profile, or you might try and flatten the curve.
That's right. And it's a really good point, because we certainly know with a lot of the farms we've looked at with this, that a lot of farms have done some fantastic revegetation and land care plantings and farm forestry over the years. And they can get to a point where they'll have enough carbon being absorbed by all of their trees that can balance out against their farm's emissions. But this increasing recognition that it doesn't stay that way forever, because the trees will slow as they get older, and this is really important for thinking of the longer term. So I really like those three: the 20 hectares in one go versus spread out over time versus another little one that you've achieved there, the flat line. And I guess one of the bits too, a lot of people saying that trees don't solve the problem of carbon and emissions on farms, but they certainly buy us some valuable time as some of these other emissions reduction technologies come on stream. So they're a really important thing.
And Graham, the other point about this is that when you look at the cumulative carbon sequestration over, say, a 50-year period for those three scenarios, there's not much difference at the end of the day.
Yep.
Which I was a bit surprised about, but I've been inside out and looked at it closely, and I think the results are true and correct. So it just tells you that yes, you can adopt quite different strategies, but you can end up with basically the same result in the long run.
Yep.
Okay.
So I guess that planting, I guess your sequencing of planting is a really important thing to try and map out, what is the plan of attack for balancing carbon emissions for the next few decades.
And the other thing that comes into play is that different species will sequester at different rates. So there are quite distinct relativities between, say, blue gum, rhodiola pine, and mixed species environmental planting. So that's another factor that needs to be taken into account. Just talking about what landholders can do. So there's a draft guideline accounting for carbon removals from tree plantings, which has been developed by Climate Active, which is an Australian government program. And one of the good things about this guideline is that you can include trees that have been established in or after year 1990. Whereas if you were to register a project under the ACCU scheme, you can't plant a tree until you've registered the project. So the good thing about this guideline is that it's giving landholders credit for the work they've done over the last 30 odd years. And I really like that.
Yeah, and so it's a draft. So, but that's with the current draft, Hugh, and I guess it hits the point here that a lot of farmers saying we've planted trees, we've taken carbon out of the atmosphere. Is there any way we can try and get that recognised, at least for how we might report against some of our products, or wool or beef or milk and grain? So here's hoping that comes through, because I think that's really good, because a lot of farmers are saying, well, carbon credits and setting up official carbon credit units through the Clean Energy Regulator is a pretty officious way to go, but also then you're selling your carbon to someone else, whereas this is more along the lines of how can farmers try and use some of the carbon that they've created from all their tree plantings and actually work it towards the farm business. So
how they can inset that carbon. Okay, so and you mentioned ACCUs. So this is an Australian carbon credit unit. ACCUs are certified financial products, so that if a landholder was to register a project, and even, for example, if they entered into a joint venture with another party to grow a plantation forest, then these are the real deal. And there's a lot of information on the Clean Energy Regulator website about the various methodologies that can be used for planted vegetation. And so it's worth having a look at that and trying to understand that a bit more if you're interested in going down that pathway.
That's right. So they're the official carbon credit units.
Yes.
So it's quite detailed, and really important people get good advice and do their homework before they enter and down that path. So
there are other tools, and so the GAF sheep and beef accounting framework is a fantastic piece of software that's been developed, and so there's all the different tools for different agricultural sectors, and that gives you a very basic look at the carbon on your property, because allows you to enter in 4 carbon areas on the farm. A carbon estimation area being an area that's planted at the same time, it's got the same species or mix of species and the same management regime. So if you use that tool, that will give you an idea what's on your farm, but bearing in mind that if you use that, it's using sort of regional calibrations out of 4CAM. It's not using a model specific to your property. So it can be a bit coarse, but it's another good starting point. And there's a lot of other tools as well. Carbon Scout software will give you a carbon heat map for your property, which you can purchase as a service. And the government of South Australia has got a website now where you can download carbon heat maps. There's a lot of information if you start hunting around. And look, Graeme, the last thing I was just going to mention was this is just some of the photographs of tree planting on our farm in 30 years. And I suppose the point of it is to illustrate that there are so many combinations that you can think about when planting trees. So here's one of those timber belts that we've planted, and those trees have been high pruned to manage for timber production. Paddy trees, really important for animal welfare and biodiversity. Small blocks of radiata pine, trees for shade, planting around farms for biodiversity and to improve water quality, a tiny niche planting in an area that was salt affected and fenced off, trees being managed for timber production, an old style shelter belt, a seed orchard, a blue gum wood lot on the property. So yeah, there are a lot of different ways that you can go about tree planting on farms. And my message to farmers is plant out all your waterways and your boundaries and those salty patches and those unproductive patches first, and then start to figure out doing land class subdivision and putting in shelter belts for livestock and what have you. And you're soon up at 5 and 10% of the property if there's undulation in the property. And then you can start thinking about in more depth about, well, what next? But we've been doing it now for 30 years and we'll keep planting trees every year because we just realise more and more the benefits of doing that.
Yeah, no, that's a great example, Hugh. We had a farm tour there recently and it was fantastic to look at all of that tree planting and the various ages of trees, but just the design of using trees to solve various sort of issues and add more diversity on the farm makes it a nice place to walk around. Actually pretty handy for lamb survival and percentages as well. Now, can I just ask on one bit? I think you investigated some of this with the MLA Carbon Neutral 30 Trees on Farms projects, but for any sort of insights into that project when you're looking at what percentage of sort of tree planting on farms and what sort of offset that might put towards the livestock portions emissions in terms of balancing it out. Did you get any feel for that?
Yeah, look, Graeme, we were fortunate to be part of AgVic's pilot program on carbon accounting on farms, and that report that was produced last year showed that the trees we planted in 30 years, which is now 18% of the property, was just enough to offset our Scope 1 and Scope 2 emissions on the property.
Yeah.
But we realise now that we're on the downward slope, so that if we do our accounts in 5 years' time, we'll probably be below the line. We've sort of come to the view, Graeme, that on our property, a mix of 80% pasture, 20% woody vegetation trees is about the right mix for our enterprise.
Yeah.
But the thing that we will be doing is we'll be harvesting some of the trees that we plant. And what that does is it generates some farm income, but it also puts some of that carbon into storage in off-site products. For example, some of those trees will be converted into lumber. They'll be made into flooring and into furniture. And in terms of the risk of loss of carbon from the landscape, having some of that carbon put into service and then the trees being replanted, I think is a really important consideration. You're thinking about how to manage carbon in the landscape rather than just planting the trees and let them grow for 100 years and hope that there won't be a wildfire during that period. So, we're very much into this planting and utilising timber where appropriate and replanting and putting carbon off-site as part of risk management.
Yeah, that's a good point, Hugh. And I think often misunderstood by a lot of folks, but planting trees on farms has lots of benefits and lots of shelter benefits. And yes, it will accumulate carbon over time, but also the whole process of planting, growing, harvesting, replanting. When you think about it, over 100 years, you can have multiple crops of carbon taken out of the atmosphere and into wood products. So it's a good thing to do, and I note there's some good resources that you're sharing, Hugh. We've got we've got the PICCC website, we've got the Trees on Farms project, as well as good resources with Agriculture Victoria. Can I just ask too, Hugh, any other sort of tips there? Have you sort of finished those web tools that we've gone through? So,
look, I've covered everything that I was planning.
Right.
I just say keep planting.
No, that's great. Thank you, Hugh. You've shared a lot of great tips and tools there today, which and just sharing those insights from someone who's come from that forest end of things, very handy for farming. And as I said, there's lots of great reasons to plant trees for shelter and shade and waterway protection and biodiversity and carbon and farm forestry. So we see lots of that, and I think the scene's set for lots more of it to happen in future. But most people who have planted trees on their farms makes the farm just a lot better place to be, for livestock and for the humans who live there too. So much appreciated, and thanks for all those great insights today.
And thanks for your hosting. Very good.
All the best.